This is Professor Pelton. This is Chapter 5, Section 1. This is Part 1. So we're going to be doing quadratic functions. So basically a polynomial to the second power, right? There are basically three general forms or three accepted forms of the quadratic function, right? Again, second power gives you quadratic. First power is linear. Third power is cubic. Okay, so first is the general form, which is an ax squared plus bx plus c, right? So basically it's in descending order of powers. You don't need to have the b or c term necessarily, but you do have to have the a term. Okay, and next is the vertex form, which we'll go through in a second as define that. And the benefit of the vertex form is the h and the k is the vertex of the parabola on the graph. Okay, and the third form is the factored form, which is known as the intercept form. That name varies a little bit from book to book, but the benefit of that is the factors themselves are the x-intercepts on the graph. Okay, so no matter what form you're in, you can do some algebra to get to any one of the other forms. The one that takes the most work is going from the general form to um, the vertex form. Okay, so if we look at this function right here, 2x squared minus 6x plus 7, if I graph it, it's going to generally look like this, and it's going to have a vertex hk, right? So if I want to determine the h and the k, I need to use the formulas from the prior page. So the h, which is the x value in the vertex, is negative b over 2a. Okay, and of course a is 2, b is negative 6, and 7 is c. So I get negative 6 over 2, or essentially 6 over 4, or essentially 3 halves. So if I want to get the k, that's essentially the y, or the function value, or f of h, right? So f of 3 halves. I'm going to plug in 3 halves of the actual function. So that's 2 times 3 halves squared minus 6 times 3 halves plus 7, right? So I get 2 9/4 minus 18 halves plus 7. So the 2 cancels there. So I get 9 halves minus 18 halves. And then if you convert 7, that's 14 halves, right? So if you add all those together, you're going to get 5 halves. Okay. All right. So there is my h value. There is my k value, right? h, k. So if I rewrite the formula, so f of x equals a x minus h squared plus k. That is the vertex form of the quadratic function, right? So f of x equals 2 times x minus the h, which I found, which is 3 halves, squared, and then the k value is 5 halves. Okay, so there is that form. So what I'm saying is the three forms that are given on the prior page, no matter what form you're in, you can do a little bit of algebra to get to any one of the other two forms. Typically, it's pretty easy. You can just distribute or factor, but this is the one that takes a little bit of work to figure out the individual values. And you can prove it to yourself that it actually is this, right? So I can take my calculator here. Um, algebra, expand. So I'm going to plug it in now. So I get what? 2 times the x minus, we'll do the ratio. The ratio was what? 3 halves. And we will square that. And then we'll add on the 5 halves. Ratio 5 halves. And there you go. If you multiply it out back, you get back the original function. All right, pause the video. Try the student problem for yourself. Okay, so the student problem, I'm going to rearrange this first. So f of x equals negative 5x squared plus 9x minus 1, right? So A is -5, B is 9, and C is -1. So A is the most important one because that's what makes it a quadratic. This is a second power. So this one actually goes down, right? Because it's a negative A. So we get our H and K, right? So H equals -B over 2A is the formula from the prior page. Okay, so B was what? 9, and the A was -5. So I get -9, -10ths. Otherwise, 9/10 is my H. Okay, so K equals F of H, because that's the, right? Because essentially the H and the K are the X and Y values, but they're specifically the X and Y values for the vertex, right? All right, so I want to actually do F of 9/10. Okay, so I need to do -5 times 9/10 squared plus 9 times 9/10 minus 1. Okay, so that gives me -5 times 81 100ths plus 81 tenths and minus 1. So convert that to all 100. So let's see. 5 times 81 is what? 403? I think so. No, 405. What am I saying? All right, so we convert that to 100. That's 810 over 100, right? And you can convert 1 to hundreds also, so that's 100 over 100, correct? All right, so if I think about what this actually over 100, or what happened there. So it's really minus 505 and then 810. So that'd be what, 305 out of 100, right? If I add that up, double check in my head here, that sounds right. So the common factor, that would give me what, 61 out of 20 with a common factor of 5, right? Okay, so my equation is f of x equals, my a value is -5, right? So then I have x minus 9/10 squared plus the 61/20. So that is the equivalent vertex form of this quadratic function, right? So basically what we're saying is this and this are the same thing. You're just in two different forms essentially. Okay. All right. That is the end of part 1.